In this question, we're told that a company has to make a large number of boxes. The company has 6 machines, and all of the machines work at the same rates. We're told that when all of the machines are working, they can make all of the boxes in 9 days. The table gives the number of machines working on each day, and so on day 1 we have 3 machines working, on day 2 we have 4 machines working, on day 3 we have 5 machines working, and on all of the other days we have 6 machines working. We need to work out the total number of days taken to make all the boxes. Now this can be a difficult question to wrap our heads around, and so we can use a diagram to help us explain this. So the company has 6 machines, and so if 6 machines are working each day, all of the boxes can be made in 9 days. And so let's take a look at diagram A. We have the numbers at the top representing each day. We have day 1 all the way through to day 9. And so each block represents the number of machines working. We can see that each block is the same height, because on each day we're saying that 6 machines are working, and so all of the boxes can be made in these 9 days. So let's say that each of these bars are full, and we're saying that it takes 9 full bars to make all of the boxes. So now that's the ideal situation. But let's use another diagram to take a look at what's actually happening. Well, now let's take a look at diagram B. We have day 1 through to day 9, and we haven't added any of our boxes yet. We're told that on day 1, 3 machines are working, and so the power on day 1 would be half of the ideal power. Looking at the bars in diagram A, this is a full bar, which means that 6 machines are working. Now if we're told that on day 1 only 3 machines are working, the bar on day 1 will only be half as tall because the power on day 1 is only half as much as it would be if 6 machines were working. And so since 3 machines are working, we can say this bar can be half as tall. Now on day 2, we're told that 4 machines are working. So this means that the power output on day 2 is slightly higher than half, but is not equal to a full bar. And we can apply the same principle to day 3. We're told that 5 machines are working on day 3, and so even though that's almost 6 machines, the bar still isn't quite full. And so we can see that on day 1, 2 and 3, each bar represents the power output on that day. We're then told that all of the other days have 6 machines working, and so when 6 machines are working, we have a full bar because that's the maximum power we can have. And so from days 4 all the way through to day 9, we have 6 machines working, which are represented by the same full bars in diagram A. Now let's take a closer look at days 1 to 3. On day 1, we have 3 machines working, and so the power is half as much. On day 2, we have 4 machines working, and on day 3, we have 5 machines working. And so we can say that these 3 days have 12 machines working in total, because 3 plus 4 plus 5 is equal to 12. And so if we merge these 3 days together, we can say that we have a power of 12. Now if each full bar has a power of 6, we can say that these 3 days, which have a total power of 12, is equivalent to 2 full bars. And so let's simplify this diagram again in diagram C. Here we have day 1 all the way through to day 9. Now we said that the first 3 days are equivalent to 2 full bars, because in diagram B, if we merge the 3 blue bars together, these will create 2 full bars. And so in diagram C, we can say that in days 1, 2 and 3, we have a total of 2 full bars. And between day 4 and day 9, we have a full bar each day as normal. And remember, in this question, we need to work out the total number of days it will take to make all of the boxes. And we said that it takes 9 full bars to make all of the boxes. And so looking at diagram C, we have 9 days. But in these 9 days, we have 8 full bars, because in day 1, 2 and 3, that's only equivalent to 2 bars. And so counting all of the bars, we have 8 full bars in 9 days. We said that it takes 9 full bars to make all of the boxes. But remember that except days 1, 2 and 3, all of the days have 6 machines working, and so each day would have a full bar. And so since we have 8 full bars, we need 1 more bar to make 9 full bars. And so if another day is equal to another full bar, it would take another day to make all of the boxes. And so we could show this in diagram D. So here we have day 1 to 9 exactly the same as diagram C. But if we add another full bar, we need another day. And so we need a 10th day to have 9 full bars. We said that it takes 9 full bars to make all of the boxes, And so we've now shown that we need 10 days in order to have 9 full bars and to make all of the boxes. And so we can say that it would take 10 days to make all of the boxes, which we can write down in the space provided. Now this question is worth 3 marks. We get the first mark for recognising that days 1, 2 and 3 are equivalent to 2 full bars. We get the second mark for realising that we have 8 full bars, but we actually need a total of 9 full bars to make all of the boxes. And we get the third and final mark for realising that in order to get 9 full bars, we need to add an extra day. And so we've found out that it will take a total of 10 days in order to make all of the boxes, allowing us to get the full 3 marks needed in this question.